In lesson 2, we define the derivative of a function as the instantaneous rate of change at a given point, which we said is the limiting value of the average rate of change in an interval. It is also a measure of the slope of the tangent line drawn at that particular point. All these are definitions of the derivative of a function. And we use the definition of the derivative of a function to calculate the derivative of a couple of functions. And I told you to remember those values. Now, in this lesson, we will develop some very simple rules so that we don't have to use that cumbersome method of taking the limiting value of the average rate of change. Now, you know that the rate of change of 7.5t, you remember this, don't you? The rate of change of 7.5t with respect to t is 7.5. That means the derivative of y equal to 7.5t is 7.5. We say like this, d by dt of 7.5t is 7.5. What does that mean? It means the derivative of the function 7.5t with respect to t is 7.5. Similarly, the derivative of 2x with respect to x is 2. The rate of change of this quantity will be 2. And how do you write that in this format? We say d by dx of 2x equal to 2. The derivative of 2x with respect to x is 2. In other words, if y equal to 2x, then dy by dx will be 2, or y prime will be equal to 2. Again, the derivative of 5p with respect to p is 5, or d by dp of 5p, the derivative of 5p with respect to p equal 5. In the first case, the independent variable is t. We take the derivative with respect to t. In the second case, the independent variable is x. We take the derivative with respect to x. In the third case, the independent variable is p. We take the derivative with respect to p. So, you know now how to find the derivative of simple functions like this. Tell me, what is the derivative of a constant? Say y equal to 5. Now, by its very nature, a constant does not change. Therefore, what is its rate of change? Well, if a constant doesn't change, its rate of change is 0. Therefore, the derivative of a constant is 0. So we say if a is a constant, then d by dx of a equal to 0. The derivative of a with respect to x equal to 0. In fact, the derivative of a constant with respect to any independent variable is 0. d by dt of a equal to 0. Is that right? All right. What is the derivative of 2x plus 10 with respect to x? Well, we can find the derivative of each of these. What is the derivative of 2x with respect to x? It is 2. The derivative of 10 with respect to x is 0. Therefore, we say the derivative of 2x with respect to x is 2. The derivative of 10 with respect to x is 0. Therefore, the derivative of 2x plus 10 equal to 2. You see, earlier we said the derivative of y equal to 2x equal to 2. And now the derivative of 2x plus 10 also equal to 2. That means a constant added to a function does not change its derivative. Is that right? Okay. We will now look at a simple rule that we can actually use to find the derivative of many simple forms of functions. That is called the power rule for the derivative. Now, you remember in lesson 2 we found the derivative of this function by taking the limiting value of its average rate of change. And we found that the derivative is 4x plus 5. We will now develop a rule so that we can find the derivative of such functions much more easily. And that rule is called the power rule. And what is the power rule? I'm going to define that for you. The power rule says if you have a function of the form y equal to ax to the power of n, a is the coefficient of x, n is its power. So if the function is of the form y equal to ax to the power of n, look at this, ax to the power of n, a is 2, n is 2. How about here? Ax to the power of 1. So all these are in this form. Then the derivative of such a function, the derivative of ax to the power of n with respect to x will be a times n, multiply the coefficient with the power, a times n times x to the power of n minus 1. The derivative will contain the power 1 less than the function. So once again, derivative of ax to the power of n is an times x to the power of n minus 1. Now let's apply it right here. Derivative of 2x squared, an, 2 times 2 is 4, x to the power of 2 minus 1 is 4x. And the derivative of 5x, you can apply the same rule. 5x to the power of 1, 5 times 1 is 5, times x to the power of 1 minus 1. What is x to the power of 1 minus 1? X to the power of 0, that is 1. So the derivative of 5x is 5, and so on. So the derivative of 2x squared is 2 times 2 times x to the power of 2 minus 1, that is 4x. The derivative of 5x equal to 5. The derivative of negative 3 equal to 0. Therefore, the derivative of the function 2x squared plus 5x minus 3 is 4x plus 5, which is the same result we got in the last lesson. Alright, let's now use the power rule to find the derivative of this function. Y equal to 10x to the power of 8 minus 7x cubed plus 5x squared minus 7x plus 3. We will take each term and use the power rule to find the derivative. Tell me, what is the derivative of 10x to the power of 8? It will be 10 times 8, 80, times x to the power of 8 minus 1, that is 7. 80x to the power of 7. Alright, what is the derivative of negative 7x to the power of 3? A is negative 7, n is 3, so it is negative 7 times 3, that is negative 21. X to the power 3 minus 1 is x squared. What is the derivative of 5x squared? Is 5 times 2 is 10, times x to the power of 2 minus 1 is x to the power of 1. And of course the derivative of negative 7x is negative 7. And the derivative of 3 is 0. We have now the derivatives of each of these terms. So tell me, what is the derivative of this function? Or what is dy by dx? dy by dx is 80x to the power of 7 minus 21x squared plus 10x minus 7, and that is the derivative of that function. A very simple way to find the derivative. So that power rule is very useful, and practice it. Let us now find the derivative of y equal to square root of x. We actually did that in lesson 2, is that right? We did it. we found the derivative of square root x as 1 over 2 square root of x. Do you remember that one? Okay, we can use the power rule to do this. How? Can you write square root of x using a power? What is square root of x as x raised to the power of what? Well, y equal to square root of x is the same as x to the power of 1/2. So, in this case, a equal to 1, n equal to 1/2, you can use the power rule. So you have dy by dx equal to 1 multiplied by 1/2, a times n, times x to the power of n minus 1, 1/2 minus 1. And that will be, this is your 1/2. And what is 1/2 minus 1? 1/2 minus 1 is negative 1/2. So that will be 1/2 times x to the power of negative 1/2. And remember, a negative power can be made positive by taking the quantity to the denominator. So x to the power of negative 1/2 is the same as 1 over x to the power of 1/2. So this becomes 1 over 2 x to the negative half will become x to the power of positive 1/2 on the denominator. And now we write x to the power of 1/2 as square root of x. So the result is 1 over 2 square root of x. The same result we obtained by using the limiting value of its average rate of change. Alright, so the derivative of square root x with respect to x is 1 over 2 square root of x. Similarly, the derivative of square root t with respect to t, d by dt of square root t is 1 over 2 square root t. Very important result. Let's find the derivative of y equal to 1 over x using the power rule, which means you need to write 1 over x using some power of x. What is 1 over x as x to the power of something? Well, y equal to 1 over x is the same as x to the power of negative 1. Is that right? And now your a equal to 1, n equal to negative 1, we can use the power rule as an x to the power of n minus 1. dy by dx is a times n, 1 times negative 1, times x to the power of n minus 1, negative 1 minus 1. That will be negative 1, that will be negative 1, x to the power of negative 2. And now we write this x to the power of negative 2 using positive power as 1 over x to the power of 2. So that will be negative 1 divided by x to the power of 2. A very important result. The derivative of 1 over x with respect to x is negative 1 over x squared. d by dx of 1 over x is negative 1 over x squared. Similarly, I can say d by dp of 1 over p is negative 1 over p squared. Or d by dt of 1 over t is negative 1 over t squared, and so on. Now tell me, what is the value of d by dx of a over x? d by dx of a over x. The derivative of a over x will be negative a over x squared. That's right. That'll be negative a over x squared. A very important result. We will be using it many times as we go on. We will now summarize some of the derivatives that we have already discussed and add to that list some standard derivatives, and that will be the list that you need to really remember. Alright, let's start with this. d by dx of a over x is negative a over x squared. d by dx of square root of x, the derivative of square root of x with respect to x is 1 over 2 square root of x. The derivative of a constant with respect to any variable is 0. The derivative of ax, d by dx of ax equal to a. Derivative of 2x equal to 2. Derivative of 5x with respect to x is 5, and so on. Now, these are the 4 results we have seen so far. And also I want you to learn some of the derivatives of trigonometric functions. I'm not going to prove them to you, but I'm going to give you the results. And these results are going to be used right through the course. So please learn them. Derivative of sine x with respect to x is cos x. The derivative of cos x with respect to x is negative sine x. The derivative of tan x with respect to x is secant squared x. The derivative of cotangent x with respect to x is negative cosecant squared x. The derivative of secant x with respect to x is secant x tan x. And finally, the derivative of cosecant x is negative cot x cosecant x. Now, these 10 standard integrals you must remember. There's no other way. So write them down several times. The way to learn calculus is actually to write them down, not to read or listen to. You need to write down and learn. Alright, what we're going to do now is to apply some of these concepts in solving problems in our everyday life. Now, the most important area where derivatives are used in solving problems is the problems involving position, velocity, acceleration, and so on. Well, if you have the position of an object described by a function, and if you find the derivative, the rate of change of position is what we call velocity. Similarly, the rate of change of velocity is the acceleration. So if I give you the position function, you can find the velocity function by taking its derivative. If I give you the velocity function, you can find the acceleration function by finding the derivative of the velocity function. But let me illustrate that with a couple of examples. Alright, let's say x of t equal to 2t squared minus 5t plus 3 is the position function. This function describes where the object is at a given time. For example, if I want to find the position at time t equal 1, I just put t equal 1 in the function. So this is your position function. And if I now find the derivative of this, if I say x prime of t, you understand what that means. X prime is the derivative of the x function, and that will be your velocity function. Now, that will be, what is the derivative of 2t squared? That will be 4t. And what is the derivative of minus 5t? It's minus 5. So this is the velocity function. And the acceleration function is obtained by taking the derivative of the velocity function. And that will be equal to 4. Now, this can also be written as, look at this, a of t is also written as the second derivative of the position function. What is the meaning of the second derivative? Now, this is the position function, 2t squared minus 5t plus 3. You find the derivative of that, you find the first derivative, and that is 4t minus 5. If you find the derivative of that again, it is called the second derivative of x. And the second derivative of x is 4. So, Velocity is the first derivative of the position function. Velocity is the rate of change of position. Acceleration is the first derivative of the velocity function. Also the same as the second derivative of the position function. Alright, we will develop these ideas again as we move on. So, velocity of a moving object is the rate of change of its position. If v of t is the velocity and x of t is the position function, then we say v of t equal to dx over dt or x prime of t. That's right. Velocity is the derivative of the position function. Acceleration is the rate of change of velocity, which means acceleration is the derivative of the velocity function. If a of t is the acceleration function and v of t is the velocity function, then we say a of t equal to dv by dt, which is v prime. But v prime is the first derivative of the position function. Therefore, a will be the second derivative of the position function. The derivative of dx by dt is called the if you have the first derivative dx by dt and you then take the derivative of that again, it is called the second derivative of x. So dx by dt is the first derivative of x. If you find the derivative of that again, you get the second derivative. Again, the first derivative of x is the velocity, dx by dt. And if you take the derivative of that again, you get the acceleration. And look at the way we write the second derivative. This is one of the notations. d squared x over dt squared. Or also, we write it as x double prime. Alright? Now, acceleration is the second derivative of the position function. That is, a of t is d squared x over dt squared. Or, a of t is the same as x double prime. v of t is the first derivative of the position function. A of t is the second derivative of the position function. I want you to know these concepts, have some understanding of these concepts. Alright? Okay. Let's do a problem using that. The position in meters of an object is given by x of t equal to t squared minus 3 over t, where t is measured in seconds. Find its position at t equal to 1. If this is the position function, how do you find the position at t equal to 1? Simply replace t by 1. To find its velocity at t equal to 1. Well, we will do that as we go on. In number 1, we need to find the position at t equal to 1. X of 1 is obtained by replacing t in this equation by 1. That would be 1 squared minus 3 over 1. That is negative 2 meters. Is that right? 1 minus 3 is negative 2 meters. It tells you that at t equal to 1 second, the object is 2 meters to the left of the origin. That's what it means, negative 2 meters. 2 meters to the left of the origin. And at that time, what is its velocity? That is our second position. And you know that velocity is the derivative of the position function. And the position function is this. X of t is t squared minus 3 over t. So to find the velocity, we find the derivative of that position function. What is the derivative of t squared minus 3 over t with respect to t? We take the derivative of each term. Use the power rule. Alright, now tell me. Leave the first term. I want you to ask this. What is the derivative of 3 over t with respect to t? We just did that. The derivative of a over t with respect to t is negative a over t squared. The derivative of 3 over t is negative 3 over t squared. So this is the derivative of t squared minus the derivative of 3 over t. And what is the derivative of t squared? The derivative of t squared is 2t to the power of 1, which is 2t, and minus, now watch those signs there, minus the derivative of 3 over t is negative 3 over t squared. And now combine the two negative signs, you get the derivative, the velocity function is 2t plus 3 over t squared. And we want to find the velocity at t equal to 1. In other words, we want to find the rate of change of the position function at the instant when t equal to 1. In other words, we need to find v of 1. v of 1 is, replace your t by 1 there. 2 times 1 plus 3 over 1, which is 5 meters per second. What it tells you is that at t equal to 1 second, that object is 2 meters to the left of the origin, and at that instant, its velocity is 5 meters per second. And as time changes, these things will change. The position will change, the velocity will change. Alright, how about the acceleration? Find the acceleration of this. Well, acceleration is the rate of change of velocity. Now, the velocity function we obtained is this. v of t is 2t plus 3 over t squared. And to find the acceleration, we find the derivative of this. A of t is dv by dt, derivative of velocity with respect to time. That will be d by dt of 2t plus 3 over t squared, which is derivative of 2t plus the derivative of 3 over t squared. Well, it's easy to find the derivative of 2t, but to find the derivative of 3 over t squared, you need to write it in a form where we can use the power rule. That means the t squared from the denominator, we should take it up to the numerator. What would that become? T squared moved from the denominator will become t to the power of negative 2 on the numerator. So that will be derivative of 2t plus derivative of 3 over t squared is 3 times t to the power of negative 2. We are now in a position to use our power rule. What is the derivative of 2t with respect to t? That is 2. What is the derivative of 3t to the negative 2 with respect to t? Use the power rule in your mind. It will be a times n, 3 times negative 2, times t to the power of n minus 1, negative 2 minus 1. Let's write that down. Derivative of 2t with respect to 2 is 2, plus the derivative of 3t to the negative 2 is 3 times negative 2, 3 times negative 2, times t to the power of n minus 1, negative 2 minus 1. And that is, this will make it negative, 2 minus, 3 times 2 is 6, t to the power of negative 3. And now in the result, we cannot leave it with a negative power. We must take it to the denominator and give it a positive power. So this will be 2 minus 6 over t to the power of 3. And that is the derivative of the velocity function. So this is the acceleration function. And we need to find the acceleration at t equal to 1. So replace your t by 1. A of 1 equal to 2 minus 6. 2 minus 6 over 1 cube. That will be 1. So that will be 2 minus 6. That will be negative 4 meters per second squared, is the acceleration at that time. All right, another one. The position in meters of a moving object is given by, look at the position function, it's a trig function. So you need to know the derivative of a trig function is y equal to sine t minus t, sine of t minus t. Find its position at t equal to pi. What is the value of y when t equal to pi? That's the question, because y represents the position. Now remember, if an object is moving horizontally, we use x for its position. If an object is moving vertically, we use y for its position. Obviously, here we have an object moving vertically, and its position is given by sine t minus t. What is its position at t equal to pi? And what is its velocity at t equal to pi? All right? And what is its acceleration at t equal to pi? All right, let's start. Y of pi, what does that mean? You see, y of t, y equal to sine t minus t means y is a function of time. So this actually is y of t equal to sine t minus t. Therefore, y of pi means the position when t equal to pi, replace in the position function your t by pi. So that would be y of pi equal to sine pi minus pi. Tell me, what is the value of sine pi? Sine pi. Sine 0 is 0. Sine pi by 2 is 1. Sine pi is 0. That's right. So that will be 0 minus pi, which is negative pi meter. In other words, at t equal to pi, the object is below the origin. That's what it means, negative pi, below the origin. And that's the position at t equal to pi. And now we need to find the velocity at t equal to pi. First of all, we need to find the velocity function. Velocity function is dy by dt, where y equal to sine t minus t. Therefore, velocity is the derivative of the position function. This is the position function. All right, now tell me, what is the derivative of sine t? Got to go back and look at that table I gave you. The derivative of sine t is, well, that is the derivative of sine t minus the derivative of t. The derivative of sine t is cosine t, and the derivative of t with respect to t is 1, because this is 1t. The derivative of 2t with respect to t is 2. The derivative of 1t with respect to t is 1. So the derivative of sine t with respect to t is cos t. The derivative of t with respect to t is 1. So this is the velocity function. Now we need to find the velocity at t equal to pi. V of pi is cos pi minus 1. All right, tell me, what is cosine of pi? You need to learn all these. Cosine of 0 is 1. Cosine of pi by 2 is 0. Cosine of pi is negative 1. That's right. So that will be negative 1 minus 1 equal to negative 2 meters per second. The velocity of the object at that time, when time equal to pi, is negative 2 meters per second. Now here I have the graph of the position function, and I have drawn the tangent line at t equal to pi, and it gives you a slope of negative 2. This is the position function graph, and that is the derivative at t equal to pi. That means the slope of the tangent line at that point gives you the velocity at that point. All right. Now, we got the velocity function as cos t minus 1. What is the acceleration function? Acceleration is the derivative of the velocity. A of t is dv over dt. Now what is the derivative of cos t minus 1? Which is derivative of cos t minus derivative of 1 actually, because we have used the negative sign already. What is the derivative of cosine of t? Derivative of cos t is negative sine t, and the derivative of negative 1, or the derivative of 1. Actually, if you notice here, that negative I have already used here. So I must say d by dt of 1. d by dt of a constant is 0. Therefore, there is nothing left there. So, the acceleration function a of t is negative sine t. And what is its value when t equal to pi? A of pi is negative sine pi equal to 0 meter per second squared. At that time, the object has no acceleration. That's what it means. Alright, another one. Find the derivative of h of x equal to 2x squared minus 3x plus 1 over x. You see, we know to find the derivative of each term. So what we need to do is divide each of these terms with x so that each is made into a form we can find the derivative of. So h of x is 2x squared minus 3x plus 1 over x. We write it as 2x squared divided by x minus 3x divided by x plus 1 divided by x. That has no problem, elementary algebra. And now we can simplify each of these and write it in the form where you can apply the power rule. Alright, this will be 2x squared over x is 2x, minus 3x over x is 3, and 1 over x is x to the power of negative 1. And now we can find the derivative of each of these by using the power rule. So dh by dx. Now look at this. Our function is called h of x. So the derivative of that with respect to x will be dh over dx. Is the derivative of 2x with respect to x minus the derivative of 3 with respect to x plus the derivative of x to the power of negative 1 with respect to x. Okay, what is the derivative of 2x with respect to x? That is 2. The derivative of 3 with respect to x is 0. And the derivative of x to the power of negative 1 is negative 1 times x to the power of negative 1 minus 1, right? Power rule. And that will be 2 minus x to the power of negative 2. And that will be 2 minus 1 over x squared. And this is the derivative of this function. Alright, try this a couple of times on your own and make sure that you understand each of these steps. How about equation of the tangent line? We did a problem in the last lesson finding the equation of a tangent line. If you know the slope of a tangent line and a point on the tangent line, we can use the equation y minus y1 equal to m times x minus x1 to write an equation to the tangent line. Is that right? Yes. Okay, let's try this problem. Find the equation of the tangent line to the graph of y equal to x cubed plus x at the point negative 1, negative 2. If you cannot see this point on the screen, mark that point. We need to find the equation of the tangent line of this function at the point negative 1, negative 2. That means x1 equal to negative 1, y1 equal to negative 2. Well, we know the point, we need to find the slope of that tangent line. Now remember, slope of a tangent line is the derivative of the function at that point. So we find the derivative of this, and we need to find the derivative at that particular x value. What is the x value? X equal to negative 1. That's right. So in order to find the equation of a line, we need its slope and the point. The point is given to us. It is actually -1, -2. Alright. Now, slope at a point is a measure of the derivative of the function at that point. So we will find the derivative of this function at x equal to -1, and that will be the slope value. And then we will use the point to write the equation of that line. Alright, our function is y equal to x cubed plus x. What is dy by dx? What is the rate of change of this with respect to x? dy by dx is the derivative of x cubed is 3x squared plus the derivative of x with respect to x is 1. Is that right? The derivative of 1x is 1. So this is the derivative. And we need to find the value of the derivative at x equal to -1, because we want the slope of the tangent line at x equal to -1. So look at the way I write it. dy by dx, this line means when x equal to -1. So read it again. dy by dx when x equal to -1, replace your x by -1. It's 3 times -1 squared plus 1 equal to 4. That means the slope of the tangent line at x equal to -1 of the graph of this function is 4. And therefore, we've got m equal to 4, and the point where we want the equation of the tangent line is -1, -2. That means this point is on the tangent line. x1 is -1, y1 is -2, m equal to 4. What is the equation of the tangent line that has the slope m and passes through a point x1, y1? y minus y1 equal to m times x minus x1. Your x1 is -1, y1 is -2, m is, remember what the value of m we found in the last slide? M equal to 4. So that will be y minus -2 equal to 4 times x minus -1. That gives me y plus 2 equal to 4 times x plus 1. And 4 times x plus 1 is 4x plus 4. And move the plus 2 from the left to the right, or subtract 2 from both sides. I'll give you y equal to 4x plus 2 is the equation of the tangent line for the graph of the function y equal to x cubed plus 1 over x at the point x equal to -1. Now here is the equation, the graph of that function. This is the graph of x cubed plus 1 over x. And I have drawn a tangent line at x equal to -1. And what is its slope? 4. And the calculator gives you actually the equation. It says y equal to 4x plus 2 is the equation of that line. And that's what we got also. Okay. There you go. So our function is y equal to x cubed plus x. This is the graph of y equal to x cubed plus x. And the equation of the tangent line at x equal to -1 is y equal to 4x plus 2. We will now look at horizontal tangent line. Now, what is the meaning of a horizontal tangent line? What is its significance? What is the slope of a horizontal line? The slope of a horizontal line is 0. That means at a point where the tangent line is horizontal, the slope of the tangent line is 0, and the slope of the tangent line at a point is called the derivative. That means wherever a tangent line is horizontal, at that point the derivative of the function is 0. Is that right? Now, let's do a problem. Determine the points, if any, at which the function y equal to square root 3x. Now, don't read it as square root 3x. Square root 3 times x plus cos x has horizontal tangent line. So what is the significance of a point where you have a horizontal tangent line? At a point where you have a horizontal tangent line, the derivative is 0. Why? Because derivative at a point is a measure of the slope of the tangent line at that point. So if the tangent line is horizontal, its slope is 0. That means the derivative at that point is 0. So a horizontal tangent line has its slope 0. That means at a point where the tangent is horizontal, the derivative will be 0. So we will start by picking our function y equal to square root 3x plus 2 cos x and find the derivative of this. Alright, what is dy by dx? dy by dx is the derivative of this term. Remember, this term is not square root 3x, but square root 3 times x. It's like 2x, 5x, and so on. So what is the derivative of square root 3 times x? The square root 3. And what is the derivative of 2 cos x? If you leave the 2 alone and find the derivative of cos x, the derivative of cos x is negative sin x. The derivative of 2 cos x is negative 2 sin x. So, if y equal to square root 3x plus 2 cos x, the derivative of that with respect to x, or dy by dx, is square root 3 minus 2 sin x. Now, we want to find points where you have the horizontal tangent line. We want to find the points where the derivative is 0. At a point where you see a horizontal line, the derivative is 0. So we will set the derivative equal to 0 and solve for x. Okay, I hope you know how to solve a trigonometric function. That's the reason why we do a trigonometry course before coming to calculus. Alright, so we set the derivative to 0 and solve for x. That means square root 3 minus 2 sin x equal to 0. And this will give solve for sin x here. Can you solve for sin x? Sin x will be square root 3 over 2. That's right. Sin x is square root 3 over 2. Alright. If you know your trigonometric values, now look at this. Sine of 0 is 0. Sine of 30 degrees is 1/2. Sine of 45 degrees is square root 2 over 2. Sine of 60 degrees is square root 3 over 2. Sine of 90 degrees is 1. Now that I was talking the input x in degrees, but in equations like this, your x must be in radians. You cannot use degrees. So let's think in degrees now, knowing that 30 degrees is in terms of pi. How much is that? Is pi by 6, isn't it? 30 degrees is 1/6 of pi, 180 degrees. So 30 degrees is pi by 6. 45 degrees is pi by 4. 60 degrees is pi by 3. So, once again, sine of 0 is 0. Sine of pi by 6 is 1/2. Sine of pi by 4 is root 2 over 2. Sine of pi by 3 is root 3 over 2. Sine of pi by 3 is root 3 over 2. So what is this x? X is arc sine root 3 over 2. And that x is therefore pi by 6 in the first quadrant. Now you must know that sine is positive in the first quadrant as well as in the second quadrant. Now those understandings are very important. Alright, let's talk about this. In the first quadrant, this is pi by 3. And in the second quadrant, you can see the angle will be 2 pi by 3, because pi by 3 is the reference angle. So in the second quadrant, this is pi. Pi minus pi by 3 is 2 pi by 3. Let me explain that one more time, because most of you are not very good at this, I know. So this angle is pi by 3 in the first quadrant. Now, that means the reference angle is pi by 3. So what is the corresponding angle in the second quadrant? This reference angle is pi by 3. That means you take away pi by 3 from pi, you get 2 pi by 3. That means if sine x equal to root 3 over 2, sine x equal to root 3 over 2, it will give you two values for x, because sine is positive in the first quadrant and also in the second quadrant. Now in the first quadrant, x will be pi by 3. Then in the second quadrant, the value of x will be 2 pi by 3. Because, try your calculator, sine of pi by 3 is root 3 over 2. Sine of 2 pi by 3 is also root 3 over 2. 60 degrees, 120 degrees. All right. So you have x equal to arc sine root 3 over 2 will give you x equal to pi by 3 in the first quadrant and x equal to 2 pi by 3 in the second quadrant. Those information is very important. So we will take one at a time. When x equal to pi by 3, this is your position function of the moving particle. So when x equal to pi by 3, then what is y? Y equal to square root 3 times pi by 3 plus 2 cos pi by 3. And if you put this in your calculator, you will get 2.8. So when x equal to pi by 3, y equal to 2.8. That means at this point, at x equal to pi by 3, y equal to 2.8, you will have a horizontal tangent line. At that point, the derivative is 0. Similarly, when x equal to 2 pi by 3, replace x by 2 pi by 3 in this function. You get y equal to root 3 times 2 pi by 3 plus cos of 2 pi by 3, and that will give you 2.6. That means the point x equal to 2 pi by 3, y equal to 2.6. Again, the derivative will be 0. You get a horizontal tangent line. There are 2 points on the graph of this function where you get a horizontal tangent line. Now look at the graph of this function. This is the graph of y equal to square root 3x plus 2 cos x. And points of horizontal tangency are pi by 3, 2.8. Now, this is the point of 2 pi by 3, 2.6. X equal to 2 pi by 3, y equal to 2.6. That is 1 point of horizontal tangency. And this is the other point, x equal to pi by 3, y equal to 2.8. You got 2 points of horizontal tangency. Very important type of problems. You must practice this as we go on. Now, we talked about position, velocity, and acceleration. And let's do another problem using the concept of position, velocity, and acceleration. For a freely falling object, the position function is given by y of t equal to negative 5t squared plus v0t plus y0. That means the position at any given time is given by this equation. v0 is the initial velocity, y0 is the initial position. All right. If v0 is the velocity when t equal to 0, that's the initial velocity, and y0 is the position when t equal to 0, where you start. A ball is thrown straight down from the top of a 220-meter building. So if you go to the top of a 220-meter building and throw a ball straight down, it means y0, the initial y value, y0 is 220 meters. That's the meaning there. Initial velocity of negative 20 meters per second. You see, something that is thrown down has a negative value. That means v0 is negative 20 meters per second. Write down the position function for the ball. To write down the position function, what all we need to do is replace the values of y0 and v0 that is given there. What is the velocity after 3 seconds? What is the velocity after falling 200 meters? Alright, this is the tower, which is 220 meters, and here's the monkey who is up there and going to throw the ball down with a velocity of negative 20 meters per second. I don't think he's going to do that, but we assume that he will do that. Okay, now this distance is 220 meters. That means initially the position of the ball is 220 meters above ground. We will take the origin as the ground. So we say the initial velocity v0 is negative 20 meters per second. The ball is thrown down with that velocity. The initial position y0 is 220 meters, and therefore the position function is y of t is negative 5t squared minus 20t plus 220. This is the position function. Well, if this is the position function, can you find the velocity function? Velocity function is the derivative of the position function y prime of t. I want you to practice these notations. Or dv by dt, or y prime of t. Now, y prime of t is the derivative of this. Find the derivative of each term. Negative 5t squared. The derivative is negative 10t. The derivative of negative 20t is negative 20. And the derivative of 220 is 0. So the velocity function is y prime t, which is negative 10t minus 20. Now we want to find the velocity at the end of 3 seconds. So what all we need to do is replace t by 3 seconds. We want v of 3. So v of 3 is negative 10 times 3 minus 20. That is negative 50 meters per second. Now let's talk about the third part. What is the velocity after falling 200 meters? The ball is dropped from a height of 220 meters. It falls all the way. After falling 200 meters, it is here. What we need to do is, we need to find the time from this equation. We need to find the time when its position, this y of t, is how much? If it falls through 200 meters, its position is now 20 meters above the ground. That's the strategy we're going to use. So what is the velocity after falling 200 meters? First, we find the time taken by the ball to fall 200 meters. Now when the ball falls 200 meters, where is it? It is somewhere here. Now, after falling 200 meters, its position is 200 minus, it has fallen through 200 meters. That means it is now at a height of, this is the position now, which is 20 meters. That's right. So it is now at a position 20 meters. That means in this equation, if you replace y by 20, we know v0, we know y0, then solve for t. We got 20 equal to negative 5t squared minus 20t plus 220. Now if you now solve this equation for t, that will give you the time for the ball to be at y equal to 20. That means the time taken by the ball to fall through 200 meters. Or I solve that equation, which will be 5t squared plus 20t minus 200 equal to 0. I'm going to leave it for you to solve it on your own. You can actually solve it on the calculator. It gives you a positive value and a negative value. Well, the negative value is not acceptable for a time. Therefore, we take the positive value. So that gives t equal to 4.6 seconds. In other words, the time taken by the ball to fall through 200 meters is 4.6 seconds. Therefore, the question we need to answer, what is the velocity after falling 200 meters, is the same as what is the velocity at the end of 4.6 seconds. So since we know v of t is negative 10t minus 20, v of 4.6 is negative 10 times 4.6 minus 20, that is negative 66 meter per second. All right, okay. We will now look at some of the important properties of derivatives. Now that's very important. I want you to pay special attention to that and learn some of the properties of derivatives. For that, let's start by looking at the graph of a function. Here you have a function graph that is, I say, concave down. It's curving down. You can have concave down or concave up graphs. Here you have the graph of the function concave down. Its shape is concave down. Now, a tangent drawn at x equal to negative 2. Well, what I'm doing here is just approximate, just for the sake of explanation. So if I draw a tangent at x equal to negative 2, there you are. Its slope is approximately 2. If I measure the slope, how do you measure the slope? Go one step forward, or one step forward, and see how much you got to rise. If I go one step forward, I got to rise almost 2 to reach the graph. That means the slope of the tangent line at x equal to negative 2 is approximately 2. You notice that the slope of this tangent line is positive. How do you know if the slope of a graph is positive or negative? If the tangent line is sloping up like this, it's an increasing function. Its slope is positive. If the tangent line is decreasing, its slope is negative. So here, at x equal to negative 2, the tangent line has a positive slope, approximately 2. Remember, slope of the tangent line is a measure of the derivative at that point. So it means at this point, the function is increasing at the rate of 2 per second, or 2, whatever the input value we use. Alright, so we say f prime of negative 2 equal to 2. The derivative of the function at x equal to negative 2 is 2. That's the meaning that the slope of the tangent line is 2. Alright, let's now draw a tangent line at x equal to 0. There is the tangent line at x equal to 0. What is the approximate slope of this graph? If I go 1 unit to the right, I just rise 1 unit to reach there. It looks like the slope is approximately 1. That means the derivative of the function at x equal to 0 is approximately 1. We say f prime of 0 is 1. Tell me, what is happening to the derivative as we move from left to right? The derivative at x equal to negative 2 is 2. Derivative at x equal to 0 is 1. The derivative is decreasing. Alright, let's find the derivative, the slope of the tangent line at x equal to 0. Let's draw a tangent line at x equal to 0. You see, it's a horizontal line. What is the slope of that line? The slope of that line is 0. So we say f prime of 2, that means that is corresponding to x equal to 2. The derivative of the function at x equal to 2 is 0. So the derivative is steadily decreasing. Alright, let's do another one. At x equal to 3, I have drawn a tangent line. Can you see that tangent line here? It's rather difficult for you to see, I think. Now, the slope of that is approximately -1. Now, look at that slope 2, 1, 0, -1. The slope is steadily decreasing. And if you draw the tangent line at x equal to 5, that will give you the slope is -3. Now, what do you see here? If the graph of a function is concave down, it means the derivative of the function decreases as we go from left to right. The derivative is continuously decreasing. So as x increases from -2 to 5, the derivative f prime x steadily decreases. So whenever the derivative of a function decreases, in that interval, the function graph will be concave down. Very important property. So where the function graph is concave down, in the interval where the function graph is concave down, the derivative of that function will be steadily decreasing. That's right. If the graph of f of x is concave down, then f prime x starts at a relatively large positive value and then continuously decreases. Now this needs to be understood in many ways. Now I can state it in two different ways. One, if the graph of a function is concave down, then its derivative will be continuously decreasing. That's right. That is the most important information that you will need to understand. If the graph of f of x is concave down, then f prime x starts at a relatively large positive value and then continuously decreases. On the other hand, let's look at the graph of a function that is concave up, is curving up. Now look at the derivatives at different positions. The derivative at x equal to -2. Now, what can you say about the derivative at x equal to -2 of this function? This is -2. And the derivative at x equal to 1 is -1. Tell me, which is greater, -2 or -1? -1 is greater. And the derivative at x equal to 3 is 2. So, if you go from left to right, in this case, the derivative steadily increases. So, if the graph of f of x is concave up, the derivative starts at a relatively low negative value and continuously increases. -2, -1, 2, 1, 2, and so on. Very important relation. If the graph of a function is concave up, in that interval, the derivative of that function will be decreasing. Alright. In an interval where the function increases, its derivative is positive. Now, what does that mean? If a function is increasing, remember derivative is a rate of change. If a function is increasing, the change will keep on increasing. That means the rate of change will be positive. Because you see, change is final value minus the initial value divided by the change in x. So if the final value is greater than the initial value, that change will be always positive. That means in an interval where the function is increasing, the derivative is positive. Does it make any sense to you? Well, look at that. If the function is increasing, then the derivative f prime x is positive. If f of x is increasing, its derivative will be constant. In other words, the slope of this line will be a positive value. F prime x is constant and positive in this case. That's right. In an interval where the function decreases, let's take the case of this function graph. This is the case of a function that is decreasing. For this x value, the function value is a large one. As x increases, the function decreases. So we call this a decreasing function. And the slope of such a line is negative. So in an interval where the function decreases, its derivative is negative. Very important relation there. So how many properties we talked about so far? Let's summarize that. In an interval where the function is increasing, its derivative is positive. In an interval where the function is decreasing, its derivative is negative. In an interval where the graph of a function is concave down, the derivative will progressively decrease. In an interval where the graph of a function is concave up, the derivative will progressively increase. That's right. Okay. Now, what's the graph of f prime x in these cases? At points where the function has a maximum or a minimum, that's the next property. At points where the function has a maximum or a minimum, look at that. If a function increases, reaches the maximum, and then turns back. Now, what is the derivative at the turning point? At the turning point, the tangent line will be horizontal. That means at a point where the function has a maximum, see something like this, at the maximum point, the tangent line will be horizontal. Similarly, at a minimum point, the tangent line will be horizontal. Like here, we have a function has a maximum value here, the tangent line is horizontal, the slope of the tangent line is 0. At points where the function has a maximum or minimum, the tangent line is horizontal and the derivative is 0. So many important properties of derivative. In the graph shown here, we said f prime of 2 equal to 0. What does that mean? The derivative of this function at x equal to 2 equal to 0. That's right. Now, look at this figure. The figure shows the graph of a function f of x. Use the properties of the derivative to sketch the graph of its derivative. In other words, we need to draw the graph of its derivative using the properties of the derivative. Now, what are the properties that we're going to use? I want you to watch and listen carefully and try to understand how the properties of the derivative is used to draw or sketch the graph of a derivative if the graph of a function is given. First of all, what I will do is I will say the function has a maximum value here. And what is the value of the derivative at the maximum value? The tangent line there will be horizontal and the derivative will be 0 there. That means at x equal to 2, the derivative is 0. That means when you draw the graph of the derivative, it will cut the x-axis at x equal to 2. In other words, this is the x-intercept of the graph of its derivative. You see, one important information. Then, if you notice here, the graph is concave down. The graph is concave down in its entire interval. If the graph is concave down, its derivative will be continuously decreasing. That means the derivative will start at a point somewhere here and will decrease. You see that? That's right. Another thing, in an interval where the function is increasing, the derivative is positive. Look at that. This function is increasing from negative infinity to 2. Up to here, the function is increasing. That means up to here, the graph of the derivative must be above the x-axis because it is positive. The positive part of the graph must be above the x-axis. So, since the function is increasing from negative infinity to 2, the derivative of the function in that interval will be positive and appear above the x-axis. That means the graph of the derivative is going to cut at x equal to 2. And up to here, the graph will be above the x-axis. And from 2 to infinity, the function is decreasing, means the derivative is negative. The derivative is negative means its graph will appear below the x-axis. That means you can draw the graph very easily now. It's a straight line coming like that, positive above the x-axis, cut the x-axis there and go that way. Let's put it down. F of 2 is a maximum. F of 2 is a maximum means f prime of 2 equal to 0. The derivative at that point is 0. The graph of the derivative therefore has an x-intercept 2, 0. The derivative graph will cut the x-axis at x equal to 2. Why? Because the value of the derivative at x equal to 2 is 0. Means its graph must cut the x-axis at that point. On the interval negative infinity to 2, f of x is increasing and concave down. Increasing means the derivative must be positive. Concave down means the derivative must be decreasing. So the derivative will start at a high value there. It will decrease. So the derivative f prime x is positive and decreasing on this interval. So f prime x means the derivative will start with a large positive value and then decreases and reaches 0 at x equal to 2. There comes the graph. There you go. So the derivative will start at a large positive value, decreases and reaches 0 at x equal to 2. Alright. F prime x is positive and decreasing in this interval. How about on the interval 2 to infinity? On the interval 2 to infinity, the function is decreasing. That means the derivative will be negative and decreasing because it is concave down. So f of x is decreasing and concave down. Therefore, the derivative is negative and decreasing. The graph of the derivative must appear below the x-axis and it must decrease continuously. Is that right? There you go. The graph must be like that. Well, it must be actually a straight line going right through. Now look at the way the information of the properties of derivatives helped us to draw the graph of the derivative when the graph of the function is given to us. Alright, I want you to practice this. It's a very important skill. So here the derivative is negative and decreasing. Let's do another one. The graph of a function f of x is shown on the right. Here is the graph of a function. Draw the graph of f prime of x using the same axis. First of all, look for maximum or minimum points, because if the function has a maximum point, at that point the derivative is 0. So we will say, well, this is where I'm going to draw the derivative graph. Alright, let's start by saying f prime of negative 2 equal to 0. What does that mean? The derivative of the function at x equal to negative 2 is 0. Why is the derivative here 0? Because the tangent line there will be horizontal. The slope will be 0. That means the derivative will be 0. F prime of negative 2 equal to 0. And f prime of 1.5. This is x equal to 1.5, and there is a minimum corresponding to that. The derivative there also is 0. That means the graph of the derivative will cut the x-axis at -2 and 1.5. The graph of the derivative will cut the x-axis at -2, 0. This is an x-intercept of the derivative graph. Similarly, 1.50 is an x-intercept of the derivative. Yep. -2, 0 is one x-intercept of the derivative graph. 1.50 is another x-intercept of the graph of the derivative. We used one information to mark the x-intercepts. Okay, let's now talk about the remaining behavior. On the interval -∞ to -2, can you tell me how the graph is behaving? The function is increasing and concave down. Increasing and concave down. How will the function, the derivative, behave? On -∞ to -2, the function is increasing and concave down. Therefore, its derivative f prime x in that interval will have a large positive value and then decreases to 0 at x equal to -2. That means the derivative will start at a large positive value. It will decrease. The function graph is increasing means the derivative will be positive above the x-axis, and concave down means it will be decreasing. That means the function graph will come like this. The derivative graph will be positive and decreasing. It will be above the x-axis and decreasing. Alright? On the interval -2 to 1.5, look at this, -2 to 1.5. Can you tell me what is the behavior of the function there? The function is decreasing. Now, if the function is decreasing on that interval, the derivative will be negative. That means the graph of the derivative will come below the x-axis, you see? So, from -2 to 1.5, the graph of the derivative will be below the x-axis because it is negative. F prime x is negative and its graph will appear below the x-axis. Some form, we will figure out the form right now. Now, to figure out the form, let's look at this. On the interval -2 to 0, look at this, the function is concave down, isn't it? The function is concave down all the way up to 0. And then 0 onwards, it is concave up. I want you to understand the concavity. Concave down, and somewhere here it's going to change that behavior. It's going to be concave up. That means from -2 to 0, it is concave down. Now, concave down means the derivative will decrease. So, up to 0, the derivative graph will decrease. And then 0 to 1.5, the function graph is concave up. That means the derivative will increase. So, the derivative graph will decrease, reaches a minimum at x equal to 0, and then increase to become 0 at x equal to 1.5. I hope you're following my argument. So, f prime x starts at 0 at x equal to -2. The derivative is 0 here. It will decrease. It is negative. Decreases to become a minimum at x equal to 0 here, and then increase to x equal to increase to 0 at x equal to 1.5. Look at that. That's the derivative graph behavior. And then when from x equal to 1.5 to infinity, on the interval 1.5 to infinity, the function is increasing. If the function is increasing, the derivative will be positive. The graph will be above the x-axis. And it is concave up, therefore it will be increasing, and that is the graph of the derivative function. Look at the beautiful derivative graph that we obtained. Now that's a very important skill. I would advise you to watch this part of the video a couple of times and understand these various concepts. Now this is an exercise taken from Math Gallery, a very good exercise to practice the properties of derivatives. Now the purpose of this little puzzle is that there are many graphs given here. You are supposed to pile all these graphs on the left side so that the function graphs will be on top, the derivative of those will be in the middle, and the derivative of those will be at the bottom. That means if you have this function graph, its derivative graph will be here, and the graph of its derivative will be below that. Alright, now let's look at something that we look for. If you here, the minimum occurs, let's say, at negative 2.5. That means you would expect the derivative graph of this function to cut the x-axis at negative 2.5 and at 0.5. So look for the graphs here. Does any graph that will be, this is 2 turning points. The derivative cannot have 2 turning points. The derivative of a function will be 1 degree lower. So you would expect only 1 turning point. So you're expecting a graph of 1 turning point, cuts the x-axis at negative 2.5 and 0.5, which I think would be this. So try and move it over here. Okay, let's do that. So move that graph over there. And then you need to look at which graph represents its derivative. If you look at this, this has a maximum at x equal to negative 1. That means its derivative graph will cut the x-axis at x equal to negative 1. Now, we have one that cutting at x equal to negative 1. And if you notice, it is concave down. It means the derivative will be decreasing all the way. That means this is probably the right one. So let's pick that and put it there. Okay, now here this is the derivative of a function you're going to put there. Which function will that be? You can see it has an x-intercept that is at 2, 0. That means the function graph must have a maximum or a minimum at x equal to 2. Now, see if any graph has a maximum. Look at this. This has a maximum at x equal to 2. And this is decreasing, positive up to x equal to 2. That means the function is increasing up to x equal to 2 and thereafter decreasing. Positive up to x equal to 2, negative. That means this is the function that will go there. Are you following the argument I'm using? So let's put that over there. What is the derivative of this? This is a negative slope. That means, well, this is a straight line, which means the derivative will be a constant. Which of the function here represents a constant function and a negative? There you got. So place that over there. And then we look at this. Now, this is a derivative graph. We must place its function graph here. Look at this. This derivative cuts the x-axis at negative 1.5 and 1.5. Is that right? That means it must have a maximum at 1.5. You see, if you look at this, this has got a maximum at x equal to 1.5 and a minimum at x equal to 1.5. That means the derivative, which is 0 at that point, and a derivative 0 at this point as well. And if you look at this, it is concave down up to here. Concave down means the derivative will be negative. Is that right? Yes. And concave up over there, that means the derivative will be positive. Does it suit it? Let's put it there and see if that will work. And does this then qualify to be that function? Let's argue it out. If this is the function has a minimum at x equal to -3, which means its derivative will cut the x-axis at x equal to -3. It has a minimum at x equal to 3. Its derivative must cut the x-axis at x equal to 3. There you go. It has a maximum at x equal to 0. That means the derivative of this function must pass through the origin at x equal to 2. Look at that. That means all this, I think, is correct. Let's check it. Oh well, it says all correct. Now what I would like you to do is use this website in Math Gallery, and you can actually do a number of these problems on your own and make sure that you understand the properties of these derivatives fairly well, so that in the next lesson we can use it. As we move on, we will use all these properties. Then you shouldn't be fumbling. You should be confident as we move on. Then you begin to understand and appreciate and really enjoy calculus. Calculus is a very, very beautiful subject which explains a lot of phenomenon around you. So take pride in learning it and enjoy it. All right?